What's up, everybody? This is page 394. We are continuing the activity 3 topic of tangent segments. So flip back and watch previous page video. Okay, in this one. Now, check it out. What we are discussing here is that the tangent segment to a circle is congruent to another tangent segment. It appears that tangent segments drawn from the same point on the circle, that is the point on the exterior of the circle, to be congruent. Let's actually go through a proof and maybe, to a degree, come up with some agreement for it. Consider this proof of the tangent segment theorem so that they are equal. AT is tangent to the circle at point T. So there's AT, and it's tangent to the circle at point T, point of tangency. And then AN is another tangent line to the circle. Tangent, point of tangency, is at N. If you connect points O to T to form radius OT, well, they didn't, so I'm going to do that. I'm going to connect OT right there. And if you connect connect points ON to form the radius ON, okay, cool. And then if you connect points OA to form the line segment OA, I'm freehanding it. Probably should use a ruler, but whatever. We know some things. We know that OT and ON are congruent because they are congruent radii. So I'm going to add some annotations to the diagram. And let's go ahead and move this video of me over here. Okay. Next up, what we have is that ON and AN are perpendicular. Tangents are perpendicular. That was a proof that we did in the previous lessons, previous topics. So we have that radii of a circle and the tangent line of the circle are perpendicular. That also puts a perpendicular here. Okay? So now what we have is that angle ONA and angle OTA are right angles, and therefore they create right triangles. So therefore, triangle ONA, being a right triangle, having congruent hypotenuse and leg through hypotenuse leg congruence through HL triangle congruence. That tells us that the top triangle and bottom triangle, they are actually congruent to each other. Now, if two triangles are congruent to each other, then, time for the highlighter, the pieces that they have in common, in this case, AT and AN, those pieces will be congruent because of corresponding parts of congruent triangles are congruent. CPCTC. Just a little annotation, some highlight, interpreting what's there. That's what you need to do when you see an example in a math text or online in a video, however you're processing mathematics. Go through it, add your own markings and details to what's there. Let's answer question 2. Question 2 says, how do you know that OT and ON are equal? I mean, they say it right up here, and my annotations actually answer it. Congruent radii. Because OT and ON are radii of the circle, that means that they have equal measures. As radii of circle O, OT and ON have the same measure. And then last of all, how do you know that the triangle ONA and triangle OTA are congruent? And I answered it back up here in my annotations. I recognize that they have a hypotenuse in common. OA is the hypotenuse, and they have a leg in common, OT and ON. So by the hypotenuse leg triangle congruence theorem, they're actually congruent triangles. So notice that OT equals ON and OA equals OA, and angle N equals, should measure here, and the measure of angle N is equal to the measure of angle T, because they're 90. By hypotenuse leg triangle congruence, triangle ONA is congruent to triangle OTA. And that's the proof. What you should do now is create the tangent segment theorem note card, which says if two tangents are drawn from the same point on the exterior of a circle, then they are congruent. That's what this page has proved. That's what the previous page wanted to make sure we were able to explain and understand. All right, so with that in mind, thank you for watching this video. There is a part 3. I want to make sure you have a chance to work through it. Click on to page 395 and keep working. Like, comment, and subscribe. See you in the next video.